Hello and welcome. I am Arabinda, your instructor for the course on bare metal embedded programming with Atmega 328 microcontroller. In today's lesson, I shall explain the build and flash process with the commands used. The AVR-GCC is the C compiler used to compile the source files. Source files are implemented using C and or assembly language. The build or the compilation process takes place in two stages. First, the C and the assembly files are compiled and object file is generated. This step is repeated for the C and assembly files individually. The object files contain the object code in ELF format. ELF stands for executable and linkable format. In addition to the object code, object files may contain metadata used for linking or debugging. These files are not executable. The "-c option in the compilation command tells the compiler to generate the object file and to skip the linking step. "-i option tells the compiler the location of the header files. "-m MCU is used to specify the microcontroller for which the compilation has to be done. "-d option is used to define the macro used in the source files. "-OS tells the compiler to optimize the code for the space. Finally, the "-o option specifies the output file name, that is the name of the object file to be generated. The second step in compilation is linking. Again, the GCC compiler is used to link all the object files and generate an executable file. The executable file is also in ELF format. The "-m MCU option has the same meaning as the earlier. It is used to specify the microcontroller for which the compilation has to be done. The "-no start files and no default libs options tell the linker not to use the standard system startup files and standard system libraries while linking. Finally, the "-o option is used to define the output file name, that is the name of the executable file. Though the linking step generates the executable file, but the generated file cannot be executed on the microcontroller as it is. It must be converted into Intel hex format and flashed onto the microcontroller. The Intel hex format conveys binary information in ASCII text form. It is commonly used for programming microcontrollers, EPROMs, and other types of programmable logic devices. AVR object copy is used for this purpose. It takes the .text and .data sections from the executable file and generates the Intel hex file. The "-j option defines the sections to be taken and "-o defines the output file format. The AVR DOD is used to program the on-chip flash memory. I have already discussed the various options used in the command. To recap, the "-p option defines the microcontroller being programmed. The "-c option defines the programmer used. "-P option defines the port. "-b option overrides the default baud rate defined for the programmer in the config file. And the "-U defines the memory operation to be performed. The AVR object dump is used to generate the human understandable disassembled instruction from the executable file. It generates a text file which is used to analyze the machine code emitted by the compiler during the build process. The "-D" and "S" options tell the tool to disassemble all the sections and intermix the source with disassembly. The disassembled instruction is useful in debugging and checking the placement of different code segments. I have provided the LED blink program which we shall compile and flash on the microcontroller. Let's quickly understand the directory structure of the source code. There are two source files, blink.c and interrupt.c, placed inside the blink folder. The blink folder is inside the code directory. Two header files are included in the blink.c. The files are res_map.h and delay.h, and these .h files are placed in the include directory. The source files are compiled from the blink directory, and the various files like .o, .hex, elf, and .asm is generated in the same directory. The source code and the handout is provided with this lecture. Follow the instructions provided in the handout and build the source code. Download the archive blink.zip and extract it. Launch the command line interface and change the directory to the blink folder inside the extracted archive. The blink folder contains two source files, blink.c and interrupt.c. The order of the compilation of the source files is not important, so I shall start with the compilation of blink.c. Use the command avr-gcc -c -i specify the directory path of the header files, and for us it is the include directory. Then use -d option to define the macros used inside the source code. I have used CPU_CLK to define the clock speed of the development board, and which is 16 MHz. The -os option is used to tell the compiler to generate the optimized code for memory usage. Then use the option -m-mcu to specify the microcontroller for which the code needs to be generated. Then specify the source file, which is blink.c. Finally, use -o option to specify the file name of the object file to be generated. Similarly, compile the interrupt.c file. Just change the blink.c and blink.o file name in the previous command with the interrupt.c and interrupt.o respectively. Here you can see the freshly generated object files. Once the object files are generated, use the command avr-gcc -m-mcu -no start files -no default libs. No start files and no default libs options tell the linker not to use the standard system startup files and the standard system libraries while linking. Then list out the object files, that is blink.o and interrupt.o. Then finally use the -o option to define the name of the executable file. Now generate the flashable image file in the Intel hex format using the command avr-object copy -j.text -j.data -o and specify the Intel hex format with ihex. Then provide the name of the executable file, which is blink, followed by the blink.hex. Let's flash the Intel hex file to the microcontroller. We have already done this step in the earlier lesson. Use the command Once successfully flashed, the LED starts blinking as shown in the development board setup. Before concluding, generate the disassembled file. Use the command avr-object-dump -ds, then provide the executable file name, which is blink, and redirect the output to the blink.asm file. You can inspect this file using any text editor. It contains the disassembled instructions along with the source code. With this, we come to the end of this lecture. Build the source code with the help of handout, experiment with the various compiler options, and develop a solid understanding of the build process.